Hey, what's going on, guys? Let's try this problem right here. Here what we are going to do is we are going to use nodal analysis method to find out unknown voltages, right? Now in order to do nodal analysis method, we have to follow all these 7 steps. Now let's start with the first one. First one is saying find the reference node with known voltage. So usually in this, for this one, what we do is we connect this one to the ground, right? So if you connect this one to ground, bottom part to the ground, that's going to be 0 voltage. Now we have a known voltage, right? Now let's look at the second part. Assign voltage to the other nodes. So here we have 1, 2, 3, and this node we already know. We put 0 voltage. And for other one we put V1, V2, and this is V3, right? And the third part is assign currents to each branch. Now we have to look at which branch doesn't have current. And if you look at this one, we have current in this branch, right? And also this branch has current. This branch doesn't have current, the top branch. So what we have to do is we have to put a current, like let's say I1, and we have the current in this one. We don't have current in this one, so we have to put something. So let's put I2 right here, and this one doesn't have current either, so we can put I3 right here. And direction doesn't matter, you can put whatever the direction you want, because if the direction is wrong, you're going to get a negative answer. So it's going to be correct anyway, right? Because negative represents opposite direction. Now we have currents in each branches. Now let's go to the next part. Apply Kirchhoff's current law to each node. So Kirchhoff current law is basically whatever the current that enter must exit. So now let's see how we can apply for this one. Here if you look at this one, 3 ampere is entering and that is exiting as Ix. So this branch is Ix, right? Ix and I1. So we can create a Kirchhoff current law in this one. So this is going to be 3 is equivalent to Ix plus I1, right? Now let's write this one a little bit top because we need a lot of space. So here we are going to put 3 is equivalent to Ix plus I1, right? Now let's go to the next part. Now let's see whether we can apply Kirchhoff's current law anywhere else. And if you notice here, Ix is entering in this branch and exiting as I2 and I3. Now we can create a current law in this branch, right? So that's going to be Ix is equivalent to I3 plus I2. Now let's look at the next part. Let's see whether we can create any more, right? Now if you notice this I1, the top one is I1, and this I3 is entering and that is exiting as 2Ix. So we can create another equation like I1 plus I3 is equivalent to 2Ix. Now we have created all the equations using Kirchhoff's current law. So this is our fourth part. Now let's go to the fifth part. Fifth part, what we have to do is define each current using Ohm's law. And if you remember, Ohm's law is V is equal to IR, right? And if you want to define current, you have to rearrange this equation. I is going to be equivalent to V over R. So here that's what we are going to do. We are going to use this one for each current we put. So first let's start with I1. So I1 is going to be equivalent to voltage drop over resistance. Now voltage drop is going to be wherever it's starting minus wherever it's ending. So here it's starting V1 and ending at V3. So it's going to be V1 minus V3 over the resistance in between. That's going to be 4 ohm, right? Now for I2, it's going to be, so it's starting from V2, right? This one middle is V2 and ending at 0 voltage. So this is going to be V2 minus 0 over the resistance in between is 4. And I3, it's starting from V2 and ending at V3. So this is going to be V2 minus V3 over the resistance in between, that's 8. Now we have created all three equations because all the currents we put. Now let's look at the next part. Substitute the current definitions into the node current equations. So node current equations is these equations, the equations we created using Kirchhoff current law. So this is first one, second one, third one. So here what we are going to do is we are going to replace all the I1, I2, I3 in terms of voltages, right? So now let's write that one, and if I begin with the first equation, in the first equation we have 3 is equivalent to Ix plus I1, and I1 is equivalent to V1 minus V3 over 4. So we can replace this one with V1 minus V3 over 4, right? So this is our first equation, and let's put the second equation. Now let's see whether we can put something for Ix. So we can create another equation for Ix. We can put Ix also in terms of voltage, right? So instead of writing like this, let's create an equation for Ix. So here we have Ix starting from V1 and ending at V2. The resistance in between, so I forgot to put this one, this should be 2 ohm right here, right? So we have 2 ohm in between and we have V1, V2. So we can create an equation Ix is equal to V1 minus V2 over 2, right? Now we can write everything in terms of voltage. So let's go ahead and start here. Sixth part we are going to substitute all the I values with voltage values. So first we have 3 is equal to Ix, we know that V1 minus V2 over 2. So we put that one right here, V1 minus V2 over 2. And then we are going to have plus I1, right? I1 is V1 minus V3 over 4. V1 minus V3 over 4. And that's our first equation. The second equation is Ix is equal to I3 plus I2. So instead of Ix, I plug this one, V1 minus V2 over 2 is equal to I3 is V2 minus V3 over 8, and then I2 is V2 over 4, right? So plus V2 over 4. And the third equation is going to be I1 plus I3. I1 is V1 minus V3 over 4. I3 is V2 minus V3 over 8. That is equal to 2Ix, 2 times this value. So 2 times V1 minus V2 over 2, right? Now we have created all the equation. Now the next step is what we have to do is we should try to get rid of all these denominators. And the best method to do this is if you find out the common denominator. For example, if you have 2 and 4, if you multiply this one by 4, all the values in the denominator will cancel. So here we can multiply this one by 4, right? And this one, the common denominator can be 8, right? So if you multiply this one by 8, all the denominator will cancel. Again, this is also same thing, multiply by 8. And if you multiply the first equation by 4, you will end up with 3 times 4, 12. 12 is equal to, this is going to be 2 because 4 times this one is going to be cancelled with 2, right? So we are going to have 2 on the numerator. So 2 times V1 minus V2, that's going to be 2 V1 minus 2 V2 plus this is going to be just V1 minus V3. And the second equation is going to be, we are going to have 4 because 8 times this 2 and that's going to be 4 on top. We are going to have 4V1 minus 4V2 is equal to V2 minus V3 plus this is going to be 2V2, right? And the third one is going to be 2V1 minus 2V3 plus V2 minus V3 is equal to 8V1 minus V2. And the next step is we have to bring all the V to the one side and numbers to the other side. So here in the first one, let's try to bring, you know what, we can solve it in this side and flip it like 2v1 plus v1, that's going to be 3v1, 3v1, and then minus 2v2, we can keep it as that, and we have negative v3, that's going to be remain the same, and in the other side we put 12. I just flip the equation, solved it and flip it, and the next equation is going to be 4v1, and we don't have any other v1, so we can just leave it as 4v1, and here we have 2v2. If I bring to this side, that's going to be minus 3v2, and we have another v2, so that's going to make this one minus 4v2, and here we have minus v3, and if you bring this to this side, that's going to become plus v3, and since we don't have any number, this is going to be equal to 0, right? And the third one, we are going to have, we have 2v1 already, and if we bring this 8v1 to this side, that's going to make this one minus 6v1, because this is going to become minus 8, so that's going to make this one minus 6v1, and then for v2 we have 1 v2 right here, so that's going to make this one 2v2, right? Plus 2v2, and v3 we have minus 2v3 here, and this is and another minus v3, that's going to make this one minus 3v3, and that's it, minus 3v3, and also here we don't have any number, so that's equal to 0. Now we have all the equations. Okay, it seems like there's a mistake right here. Let's see, 8v1, okay, this one's supposed to be 8v2, so here we multiply everything by 8, so I multiply v1 by 8, but I didn't multiply v2 by 8, so we are going to have 8v2, so that's going to make this one 9v2, right? So this is going to be 9v2. Now everything is again here we have 8 times plus this is 2v2, and in the other side we have 4v1 minus 4v2. Okay, this should be a 4v2, right? (4v2), and if I bring this to this side, that's going to make this one minus 6v2, and this is going to be minus 7v2. So here we are going to have minus 7v2. So 3, 2, minus 1, 4, minus 7, 1, and minus 6, 9, minus 3. So now everything is correct. Now the best method to solve this one is using Cramer's rules, right? So Cramer's rule is what we do is we take the matrix, take this one in matrix form. Like if you notice the first one, 3, right? 3 minus 2 minus 1, and in the other side we are going to have 12, and here we have 4 minus, I use a different color, that way it will be more clear. So I just take these coefficients, so 3 minus 2 minus 1, 12, and then 4 minus 7, 1, 0, and minus 6, 9, minus 3, 0. So this is going to be our matrix form of these equations. Now if you studied linear algebra, you know how to do Cramer's rule. I show you how to do that. So let's get rid of this one. We don't need this one anymore. Let's keep this I equations, because after finding voltage we can solve for I2, right? So let's get rid of this part only, and maybe also get rid of this one, right? Okay, so now let's find the v1, v2, v3. So now the idea is we take the determinant. So if you want to find v1, right, what you do is we take the determinant, and for v1 we know that first column is v1. So what we do is we swap this one with first column in order to find v1. So whatever you are trying to find, you have to swap with that. If you want to find v2, you have to swap this one with v2 and others remains the same. Now since we are trying to find v1, we are going to swap this 1200 to the first column because first column is v1 column. Now if you swap that one, that's going to be 1200 and others are going to be -2, -7 and 9, -1, 1, -3, right? And in the bottom you have to divide this one by determinant and the original determinant, that is 3, 4, -6, -2, -7, 9, -1, 1, -3, right? So here, if you don't remember how to find determinant, what we do is we put plus minus plus, right? Plus minus plus, and if you take the first term, for example, if I want to find the determinant for the top one, what I do is I take the 12 common, right? Then if I take 12 and if I take 12, what's going to happen is all the vertical and horizontal common is going to be eliminated. So we are going to left with -7, 9, 1, -3. So what we have to do is AD minus BC. AD minus, if you have ABCD, AD minus BC, right? So that's the generic equation to find the determinant. So here we take 12 and AD minus BC is going to be 21. So -7 times -3, that's going to be 21. Minus BC, so -9. And then -2, that's going to make this one +2, right? And so if I take -2, all the vertical and horizontal will be eliminated. So we are going to have this one. But others, it seems like others are going to be 0 because others are going to be 0 because we are going to multiply 0 times -3, 0 times 1, that's going to make this one 0. So this is easy, right? And the third one also going to be easy because if I take -1, so this is going to be -1 right here. If I take -1, all the vertical and horizontal of -1 will be eliminated. We are left with 0, -7, 0, 9. And again, if you multiply, you will get 0. So these two are going to be 0. So only this value is matter. And in the denominator, we are going to have 3. And if you take 3, all the vertical horizontal eliminated, we are going to left with 21 minus 9. And the next one is going to be -2, that's going to make this one +2. And all the vertical horizontal cancel, so we are going to have 4, 1, -6, -3. So that's going to make this one 4 times -3, that's going to be -12. And -6 times 1, that's going to be -6. Since we are subtracting, minus minus, that's going to make this one plus. And the third one, we are going to have -1. And here, if I take -1, all the vertical horizontal eliminated, you will end up with 4 -7 -6, 9. 4 times 9, 36. Minus 7 times 6, 42. So this is going to be plus 42 because minus minus plus. Again, we are subtracting, so it's going to be -42. And if you simplify this one, you will end up with these numbers. Like the first one, you're going to have, let's see. So in the bottom, we get 30 for the first one because 3, and this is going to be -2. Okay, wait. If I take 3, it's going to be 21, right? 21 minus 9, that's going to be 12. 12 times 3, that's going to be 36. 36, and this is going to be -6. -6 times 2, -12. So 36 minus 12, you are going to get 24. And this is going to be 36 minus 42, that's going to be -6 plus 6, so you will get 30. If you add them together, you will get 30. And from this one we can sort everything, like you will get, so first for the first one you will get 144 on the top. So this is going to be 21 minus 9, that's going to be 12. 12 times 12, that's going to be 144. 144 over 30, and you will get 4.8 volt. Now you know that how to do the determinant. So you have to do the same thing for V2 and V3. So for V2, the difference is, instead of swapping this one with first column, you have to swap this one with second column and find the determinant. And if you find the determinant, you will get 72. And the bottom determinant always going to remain the same, because bottom determinant is the determinant of original form. So it's going to be always remain the same. And if you calculate V2, so this is V1. V2 is going to give us 2.4 voltage. And if you do the same thing for V3, you will get negative 72 over 30, and that's going to give you negative 2.4 voltage, right? Now we have all the voltages, and you can substitute this one in this equation to find the currents if you want. Here our main purpose is to find the voltage, right? And also if they ask for current, you can find it. Just plug the values. We have V1, V2, V3, and if you plug it in the first equation, you will get 1.8 ampere. I1 is going to be 1.8 ampere, and I2 you will get 0.6 ampere, and for I3 you will get again 0.6 ampere. For IX you will get 1.2 ampere. So these are the values you will get if you substitute all the V2, V3, V1 values and find out these currents. I hope you guys find this video helpful. See you next time.